Okay guys, welcome. And we are here to discuss about theory of combustion. So the, here are some kind of like questions. So what makes a fire burn? Why is one a roaring inferno while the other just slowly just follows along? And the answers we will find that about in the next slides. So combustion, also called rapid oxidation reaction, and is a combination of fuel and oxygen to form carbon dioxide, water, and heat. Rapid oxidation are chemical reactions that give off heat. It is similar to the formation of rust in iron or the decay of dead wood in the forest. But the difference is that the process is only sped up. So, as of the two major types of combustion, number one is flaming, means that both fuel and the oxygen are both in the gaseous phase. Glowing means that the fuel is solid and only the oxygen is in the gaseous phase. So when forest fuels burn, there is a chemical combination of the oxygen in the air with woody material, pitch, and burnable elements found in the forest environment, which is an example of combustion where it is a chain reaction chemically similar to photosynthesis but only in reverse. The photosynthesis, just a little, it requires a large amount of heat, which is furnished by the sun. But in terms of combustion process, the combustion itself is the one that releases the heat. And the tremendous heat that is produced in the burning process is a major reason that the suppression of wildfires is such a difficult task. It is also why the use of prescribed fire is a complex and exacting process requiring knowledge and experienced people. And also, other definition is the process for combustion is the process of rapid oxidation of or burning of a substance with simultaneous evolution of heat and also light. The combustion of solid or liquid fuel takes place above the fuel surface in a region of vapors created by the heating fuel surface and the heat that can come from ambient conditions, ignitions, or from already existing fires. In short, it is the scientific word for burning. And prerequisites or requirements for combustion is number one, there must be fuel to burn. Number two, there must be the air to supply the oxygen. Number three is there must be heat or an activation energy or the ignition temperature depending on what kind of material you are or something that is trying to burn or combust to start and continue the process of combustion. As for the types of fire combustion, well, we'll see about that in the next page. Number one is complete combustion. This type of combustion occurs when there is an unlimited supply of air or oxygen. That also said, let's just say for an example, it also depends on what kind of material or how small or big it is. And also depending on how fast the fire, let's say, consumes the fuel or the oxygen. And an exothermic reaction occurs between the carbon and hydrogen atoms of a hydrocarbon fuel with oxygen. An exothermic reaction is a chemical reaction that releases energy from the system in the form of heat. The hydrocarbon will burn completely and leave only two byproducts, which is carbon dioxide and water. An example of complete combustion is, well, a candle. The heat evaporates the wax from the wick, which combines with the air, oxygen in the air. Water and carbon dioxide are two byproducts of the process as said earlier. In an ideal case, all the wax is consumed and combustion is complete. Number two is incomplete combustion, wherein is a type of combustion that takes place when there is a limited supply of air or oxygen. Although there's still water produced, and it produces and also produces poisonous carbon monoxide and carbon. Compared to complete combustion, it just produces less energy since, as said in its type, it is an incomplete combustion. And also rapid combustion, combustion in which a substance burns rapidly, produces heat and flame. It's also known as rapid combustion. It is also known as fast combustion. So, this is usually attained by introducing external heat. Substances that undergo rapid combustion and have lower ignition temperatures, mostly gas, I think, and examples are what you can see is LPG, CNG, petrol, and etc. And also liquid products. So, as of spontaneous combustion, it is when a substance suddenly turns into a flame without the supply of an external cause such as heat, and substances that have relatively low ignition temperature burn by spontaneous combustion. And some examples are phosphorus and sulfur start burning instantly at room temperature. Haystack, linseed oil, coal, pyrite, and etc. sometimes start burning suddenly with flame because of the increase of temperature. That's kumbaga natural cause. Also in coal mines where fire breaks out many times because it is mostly due to the combustion of coal dust, and I think also because of spontaneous combustion, the where spread flour ngai, you can use it, spread it in the air where they spread in particle like types, and I think you can just ignite them while they are in the air. And also fire often breaks out suddenly in forests because of an increase in the temperature due to the sun. As of explosion, when combustion is accompanied by sudden production of heat, sound, and a large amount of gas. This type of combustion occurs at an extremely rapid pace. And firecrackers and bombs also undergo an explosion. The fireworks bursts when sparks ignites the fuse for producing heat, light, and sound. And as for the classification of fuels or combustibles, let's see. Class A is where carbonaceous. These are any ordinary cellulosic materials that easily burn and some ash may be left behind. Examples are wood, paper, cloth, trash, plastic, solid combustible materials, which are not metals. While in Class B is that it involves flammable liquids, which are gasoline, oil, grease, acetone, and any non-metal in a liquid state that is on fire. In Class C are the electronics and energized electrical equipment. As it is plugged in, actually it would be considered a Class C fire if it does caught on fire. And Class D are the materials like metals and like which are like potassium, sodium, aluminum, and magnesium. And yep, that's it. That's the end. And I would just say thank you guys for listening in, and see you next time, I guess. So, bye bye.